definitely optional, so just by saying that word, I think I lost more than half of you, but it's okay. If you're very confident, then you don't have to worry about this. But if you need a little bit extra, then this might be for you. Let's see. Let's start quick. So I'll make a short video. We can combine like terms, and in this case, this and -7. So it's -24 and -7. So it's -31 AB minus 6B. Okay. So you got to really be careful with your like terms and the sign that comes with it. So that's the difficult part, I guess. Let's do it in order of exponent here. So 9r squared comes up front, and that combines with num1. And then we can do alphabetically the p's. Minus p and minus p is, right? Remember, there's a 1 in front of it, so it's literally -1 minus 1, and that should give us -2p, and finally minus 8r. Okay, so let's move along. Just make some room here. Okay, this one. Again, it's just combine like terms. C minus C is just 0, so that goes away. 6v squared positive minus 4v squared is 2v squared minus 2c. A2b3, is there an A2b3? Yes, there's one all the way one in the back. And it's minus A2b3 and minus A2b3, so that's going to give me -2 A2b3. And then I can combine these two, right? Because there's both b cubed, and that gives me negative, careful here, -22 b to the third power. Distributive property, again, factor outside, multiplying every term inside the parentheses. Negative times a positive is a negative. 5 times 7 is 35n. Negative and negative is positive, and 5 times 5 is 25. Can I combine anything? No. Imagine there's a -1 here, but we already talked about this so many times that you really don't have to. But there's a minus sign in front of the parentheses, which means when the parentheses are removed, everybody comes out the opposite, right? Over here, distributive property again. So again, there's a 1 here and there's a 1 here. 3 times 1 is 3, and then we're going to multiply the variables. X squared gives me x cubed. Keep the base, add the exponent. Y4 and y6 gives me y10. Plus, and again, 3 times 1 here is again 3, and then x times x is x to the second power, and then y4 to the y second is y to the 6, add the exponents. There's nothing outside the parentheses. There is an invisible 1, and it's positive, right? So when you remove the parentheses, if you do the distributive property, they come out exactly as they were inside the parentheses. No big deal there. Oops, sorry. Let me move this a little bit. Distributive property combine. Okay, so this one. 4/7 times, and again, 4/7 times 42. Let me just take that to the side here. That's what this looks like, right? I'll put it over 1, you can put it over 1. So when I'm doing this, I'm not going to multiply 4 times 42 and then divide it by 7. I think that's a little bit too difficult. I do this in my head. I simplify 47 and 7. 42 and 7 gets me 6. And 4 times 6 is 24. So negative and negative is a positive, and 4/7 and 42 is 24. A squared and c multiplies with no one, but it's still part of my term here. Next one, so we did this. Negative times a positive is a negative. 4/7 and 21, and again, I'm doing 21 divided by 7 in my head, and that is 3, and then 4 times 3 is 12. A squared times a squared is a to the 4th, and c times c is c to the 2nd power. And last one is, again, positive, and again, 4/7 of 56. 56 divided by 7 is 8. 4 times 8 is 32. A squared multiplies with no one, but c times c is c squared. Can I combine my terms? No. 2/3 of 15. Again, same thing. 15 divided by 3 is 5, and 5 times 2 is 10, so I get 10 in. Positive times we did this, sorry. Positive times a negative is a negative. 36 divided by 3 is 12, times 2 is 24b. Minus, and then there's a 1 here. 2/3 times 1 is just 2/3 g. So now this one, we probably have to combine something. All right, so let's start. Distributive property first and then combine like terms. All right. So this is going to be positive. 12 times 5 is 60. B, c to the second power. Positive times a negative is a negative. 12 times 4 is 48. B. Plus the 12b that's patiently waiting, and the 8b c squared was patiently waiting as well. Can I combine like terms? Yeah. This one and this one are like terms. And this one and this one are like terms. Now, you don't need to move the like terms together. It's nice to have the like terms together, okay? But if you don't want to, that's okay. I'll just do it because I have no reason, but I'll just do it. And then 60 minus 8 is 52. B c squared, right? We keep that part the same. We don't do anything to our variables. And negative 48 plus 12 is negative 36. And B. Yeah. A fifth, so okay, so the distributive property. So we're multiplying. In this case, we're multiplying. So a fifth times a to the second is negative a to the seventh power. A fifth times negative 8, so negative 8 is negative a to the sixth power. Remember, we keep the exponent, and we add the, sorry, we keep the base and add the exponents, and then minus a7 and minus a. Can I combine like terms? Yes, I can. This is a like term as this. So if I put them together, I get a7 minus a7 minus a7 minus a6 minus a. I can combine these two and write it as negative. There's a 1 in front of them, so negative 1 minus 1 is just negative 2. A to the 7th, a to the 6. Again, distributive property before we combine like terms. So this is going to give me negative and a positive is negative 6p squared. Negative and negative is a positive, and that's going to give me 3p squared y. Plus 7, that 7 does nothing. And then the second distributive property. Negative and positive is a negative 3p squared, and then finally negative 3p squared times y cubed is going to give positive, because a negative times a negative, 3p squared y cubed. Anything that I can combine? Ugh. Yeah, yes, I see. This guy and this guy are like terms. Alright, so negative 6 and negative 3 is just the same thing as negative 9. P squared plus 3py plus 3py cubed, which should have gone first, and then plus 7. So I wrote it a little bit out of order, but regardless, that's your answer. Negative 5h is just going to hang out for a while. These two is where the distributive property happens. Negative times a negative is a positive. 4 times h is just 4h. Negative times negative is another positive. 4 times 9 is 36. Plus 11h minus h. Combine like terms. This, 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 and this. They're all like terms. So in this case, negative 5h plus 4h plus 11h minus h, and then let's put the 36 all the way in the back. So I know 36 does nothing, so it's going to be plus something plus 36. Negative 5 plus 4 is negative 1. Negative 1 plus 11 is positive 10, and 10 minus 1 is 9h. And hopefully I'm correct. Okay, so we got a couple more. Okay, so again, distribute and combine. Negative 24k, distributive property happens here, and it's going to happen here again. This is going to be negative 8k plus 4m, right? Minus 9k, that's just hanging out there, and there's a 1 here. Negative and negative is positive, and negative 1 times n, negative m is positive m. And negative 1 times negative 15 is positive 15k. Can I combine anything? Yeah, there's a k here, there's another k here, there's another k here, another k. And all the k's will be combined together, and all the m's together. So let's do the m's because that's easy, right? 4m plus m is just 5m, positive. And if we do the k's, negative 24, negative h is negative 32. Negative 32 and negative 9 is negative 41. And negative 41 plus 15, ugh, negative 26. Okay. Superior property happens here. Sorry, here. Negative times negative is a positive. 10, that's going to give me 8m. 4/5 of 20. So first of all, sorry, negative times a positive is a negative, and 4/5 of 20 is going to be 16. Negative and negative is a positive, and again, it's going to be 16 again. C, this time it has a C, and then the minus C and the minus 17m. Like terms, 8m, and this guy is a like term. 16c plus 16c and minus c is another like terms, and this guy is your constant all the way by itself. So 8m minus 17m is negative 9m. Okay, and then 16c minus c is just plus 15c, and that's my expression, my answer. Oops. Right? We need to get rid of the parentheses, right? So we can combine like terms. So negative 20 is just going to do nothing. Negative 2/3 c times 15 is negative 10c. Negative and negative is a positive, and 2/3 c of 9k, well, we're multiplying. Oh no. The charge, sorry. So negative and the negative is a positive, and 2/3 of 9, well, 9 divided by 3, 3 times 2 is 6. 6ck. Don't forget the variables. The second one, negative 2/9 times 36 is going to be negative, first of all. That's going to give me 8. Negative and the negative is going to be positive, and 2/9 of 18c is going to be 4c. Like terms? This guy and this guy. The c and this is like terms, and that one is not. So negative 10c and 4c is negative 6c plus 6ck, and then negative 20 and negative 8 is negative 28. There's an invisible 1 here if you want it. If not, just, you realize that, remember, when there's a minus sign in front of parentheses and we remove the parentheses, everybody comes out the opposite. When there's a plus sign in front of parentheses, well, they just come out as they are. So b is positive, and that a is negative. It comes out exactly as they were inside the parentheses. Combine like terms. This a and this minus a, well, a minus a is just 0, so those two are common. 7b plus b is just 8b. Okay. I'm not going to do the next section because it's already on the previous video. Okay, but I'll do this section over here. So we want to use the greatest common factor. We have to, because that's what the question's asking. So let me write this maybe this way. 15 A, B, 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 if you want to. 12, there's 5 A's, 6 B's, 3, 4, 5, 6, 3. I mean, eventually you won't need to do this because you'll see it, but outside the parentheses is what they have in common. So what do they have in common as far as the coefficients? 15, 12, 3. What is the greatest common factor? The greatest common factor between 15, 12, and 3 is just 3. Do each term do they share A's? Is there a certain amount of A's that they share or not? In this case, they do. They each have 2 A's. So I'm going to cross that out. 1, 2, 1, 2, and 1, 2. And I'm going to take it out and put it out here. Do they share B's? But again, make sure that each of the terms share B's. And in this case, they do again. Excuse me. They have 2 B's. Every term has at least 2 B's. Now comes the easy part. So we need the first term, right? We need to know 3a squared b squared times what gives you this? Well, 3 times what is 15? It's 5. Well, of the a's that we cross, how many a's are left over? 1a. And how many b's are left over? B to the second power. So just stop for a second and double check. 3 times 5 is 15. Check. A squared times a is a to the third power. And b squared times b squared, b to the fourth. You're good. 3 times what is 12 would be 4. How many a's are left over in here? Okay. Well, we have an a2, and inside should be an a5, so definitely a to the third power. And b second is outside, and we need to get b6 here, right? So we need to put there b4. Right, and there's 1, 2, 3, 4, and there's 1, 2, 3 aces, so leftovers, right? And 3 times what is 3? It would be just 1. And we need to get 3a squared b squared. We can't add any a's and b's here because otherwise we'll get something different. So that last term is just 1. And again, you have plenty of time to just do this really properly, right? And make sure that you get this expression here. All right, likewise, 42, and again, I don't know how many of you are doing this. You don't have to, if you can see it. 1, 2, 3, 4, 5 n's and 1 w. 20 is 1, 2, 3 n's. 4, 1, 2, 3, 4, 5, 6 n's and 1 w. All right. Where's the greatest common factor between 42, 20, and 4? And that would be 2. They share any m's? Do all the terms share m's? No, so that we can't take out. Do they share w's? No. Do they share n's? Yes. Everyone has n's to share. So what is the greatest number of n's that they share? It would be 3 n's. 1, 2, 3 n's here. 1, 2, 3 n's here. And 1, 2, 3 n's here. So I'm going to take that, and that's going to go outside. That's it. So what are our 3 terms? Well, 2 times what is 42 is 21. But make sure we want to get this, right? So 21, we need m's, so it's going to be m to the 4th. We have n third outside. We want to get to n fifth, so we're going to write n to the second power. And we also need to put a, let me erase this. We need to put a w there. So 2 times 21 is 42, and 3 times n to the second is n5, m4 is there, and w is there. Check. 2 times what is 20? It would be 10. And that's it, because n cubed is already outside, so 2 times 10 is 20, and n cubed will be multiplied as well, and it's already there, so that's okay. The last one, 2 times what is 4? It's 2. But we need to get n6w, so what do I multiply n3 to get n6w? Well, you need to multiply by another n3 and a w, and that will get you this. This one's super hard. They share absolutely nothing. So 1 is the only factor that I have in common. And there's my answer. If you wanted to pull out a -1, you could have done that, but in that case, then everything inside would be opposite. So it doesn't matter if you did it this or did that. Greatest common factor here, and I'm going to do it, is 6. They share x's. Yes, everybody has 1x. They share y's? No, not everybody has y's and z's. No. So 6x is what they share. 6x multiply what will give me 15xy? Well, 6, oops, sorry, did I say 6? Should have been 3. So it's 3 times 5. And I need to get xy, so I need to add a y there. 3 times 5 is 15, and x times xy is xy. Good. 3x times what gives me 12x? It would be just 4. 3x times what will give me 6xyz? Would be times 2. yz. And then 3x times what will give me 30xz, or well, 3 times what is 30? It's 10. Well, the x is already there, so I don't need the x, but I need the z. Again, if you're unsure, just do the distributive property. Let's see if you get the original expression. This is just a distributive property twice. And then if you combine like terms, So it's this first, and then, right? So negative 3h times h is negative 3h squared. Negative 3h and 9 is going to give me negative 27h. And then we're going to do negative 4h, which is negative 4h. And negative 4 times 9 is going to give me negative 36. Is there anything to combine? Yeah, these two I can combine. Negative 3h squared, that stays. 27 and negative 4. Negative 27 and 4 is negative 31. H minus 36. Same thing. Distributive property twice. 3c and 15m is 15cm. 3c times negative 12, first of all, is negative, and then 36c. Second one, negative 4 and 5m is negative 20m. And negative 4 and negative 12 is positive 48. Can I combine anything here? Nope. Which is good, because you have less to do. Remember, we're multiplying here. So the product rule comes into play, right? If the bases are the same, you keep the base, you add the exponents. Well, let's do these two. And then these two. Positive and negatives are negative. 3 times 4 is 12. And then x squared times x to the third power is x to the fifth power. Positive times negatives are negative. 3 times that invisible one is 3. And then x squared y6. Second part, negative times a negative is a positive. 2 times 4 is 8. And then x cubed y, because they're not the same base, so I can't do anything. And lastly, negative times a negative again is a positive. And there's an invisible one. 2 times 1 is just 2. And then y to the, keep the base, add the exponents, y7. Like terms? Absolutely not. Same thing here. Negative 15am. Second one's going to be positive and negative, so it's negative 5m squared. Bottom part here, positive, right? 12, and then 8 to the third power. And negative times a negative for the last one is going to be positive, and 4 times that invisible one is 4, a squared m. Like terms? No. Okay, careful. am, this is a squared m. All right. I choose better music. This looks like a negative, so they're both negative. 6 negative 8 is going to be 48 positive. m5 times m5 is m to the 10th power. A lot of ways you can do this. So again, we're multiplying. So 6 times 2 is 12, and then n negative 7, n negative 3, they're being multiplied. But so we can keep the base and add the exponents. Negative 7 plus negative 3 is negative 10. Remember, you should only have positive exponents. So what can we do here to change that to a positive exponent? Well, the 12 is going to stay, and then we're going to use the reciprocal, but with a little twist here. We're going to using the reciprocal, but the n to the 10th power becomes negative 10th power, becomes m to the 10th, positive 10th power. It's one way of doing. Some of you might have done this right away. Let's see. You could have multiplied 6 times 2 and got 12. And then you could have thrown the n to the 7 down here, making it positive, and thrown the n to the third power, making it positive. And then you can apply the product rule, right? N to the 7 and times n to the third, n to the 10th. Notice that you get the same answer. It's just a matter of choice. Here, let's multiply 2 multiplies with that invisible one, so that's just 2. a5, a6, keep the base, add the exponents. b negative 5, b3, you can keep the base again and add the exponents, and you get negative 2. And then now, you'll change that, right? So the 2 stays up, A to 11 stays up, and B to the second goes down. That's one way of doing it, and again, I'll do it the other way. You could have done this, 2, A5, A6, well, you can combine that right away. And then B to the negative, you could have thrown it down here, and B to the third stays up here, which now you would have, what do you call, simplified. Well, there's nothing simplified with 2. A11, no. But B3 and B5, they're going to cross that out, right? Remember, B to the third power is B, 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 and B to the fifth is B multiplied by itself 5 times. We can simplify. These two go away, go away. They all become 1, and we're left with B to the second power, which is exactly what we got. Now, be careful here. We can apply the product, the expanded rule, right? So that 5, and make sure you put a 1 there. So that 5 is multiplied by this, multiplies by that. And we're going to get negative 2, right? And then I want you to put that in parentheses, negative 2 to the fifth power. Now, well, why not? Negative 5 to the fifth power, and then m to the 15th power. Now, it's negative 2 times negative 2 times negative 2 5 times. That's an odd number of factors being multiplied, so that's going to give me negative, right? 2, 4, 8, 16, negative 32. M 15. So, another way of looking at that is this way. And maybe that'll explain a little bit better why it's negative. Well, so if you think about it, it's negative times negative times negative times negative times negative, right? And that's going to give us negative 32. M3 plus M3, sorry, m to the third power times another m to the third power. We can keep the base and add the exponents, and that's going to give us M15. All right? All right, so we're moving. Again, same thing here. I want you to be really careful here. Right, there's a 1 here, so that gives me 5 to the negative third, m to the positive 21, and n to the negative 15. You're not going to leave this like this because it has negative exponents. So 5 to the negative third is going to come down here. M21st is positive exponent, so no changes. And n to the negative 15 comes down here. We can switch 5 to the third to 125. But everything else, we can write where it is. And it should be your answer. I want to make some changes here. 3 stays, 8 to the negative third power comes down. So let me cross this out. That's gone, that's gone. B to the fourth will stay up. 8 to the negative 7 is going to come up. And B to the 9 will stay down. Oops, sorry. This should be 8 to the third power, positive. Can I simplify now? Well, the 3 simplifies with no more. But the A's, I have A3 and A7, right? 8 to the third power at the bottom, 8 to the 7 on top, which means after we simplify, we're going to have 8 to the fourth left over here. B4 and B9, again, after we simplify, we're going to have 5 B's multiplied by itself left over in the denominator. And that's your final answer. Right, so here we go. Ooh. 2. Right, just you know what? Let's do this. 2. I'm going to leave the x to the fourth. Let me put this as a fraction. Y to the negative fourth is going to come down. Z to the negative third is going to come down. 3 stays. X to the second power stays. Y to the negative 3 goes up. And z to the fourth power stays as it is. Can we make this look a little better? 2/3 is just 2/3 as a fraction, right? Nothing we can do. X4 and X2, they're going to simplify, and you're going to have X2 left over in the numerator. Y3, Y4, Y to the third and Y to the fourth, after you cross out, you're going to have 1Y left over here. And z to the third, z to the fourth, we can use the product rule and just simply write z to the seventh. So, careful here. I think I did this on purpose. It's negative 4 right? So remember that this. So if I took that x to the negative third power, I would have this, right? What does that look like? What does that equal to? It's negative 4 times negative 4 times negative 4 times negative 4 times negative 4. Right? It's negative 4. So if you use your calculator, which you will have tomorrow, 4 to the power raised to the fifth power equals 1024, pero negative, right? And then x negative third power to the fifth power is just x to the negative 15. And then if we rewrite this using positive exponents, it's going to be negative 1024, and that x15 comes down here. Here, very careful. And again, let me sort of separate that. Imagine if that was this. That would be negative 3 times negative 3, right? So negative 3 times negative 3. So, and then if you can multiply that, and then, but I just wanted to show you that that's going to be obviously positive. So we're going to get negative 3 to the second power, and then x to the fourth power. Okay. So that's going to give us 9x fourth. Okay, so again, my concern is that you're going to say, why is this positive when that 2 is only? But think about it. It's, in this case, maybe you should write it like this, right? Because if I remove the x squared and I leave the negative 3, this is what it looks like. And that's negative 3 times negative 3. And that's why I got 9. So be very, 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 very careful. That's it. Okay, so you can change the numerator and denominator, right? You can rewrite it and make the exponent positive if you want right off the bat. It's really up to you. There's a little 1 here. I'll put the 1 there. So I'm just going to go negative 3 to the negative fifth power, a to the 10th. I'm multiplying the absolute exponent by every exponent in here. B, don't forget the B has a 1 in here, so that's going to be B to the negative fifth. C to the positive 25th. All that over, again, a to the positive 5. B4 times negative 5 is going to be b to the negative 20th. And c to the second power times c to times negative 5 is going to be c to the negative 10th. Sorry, that parenthesis should be a little bit bigger. No, I don't need it anymore. Okay, so let's move things around. That fell over here is going to come down here. And the exponent is going to be positive. Okay, so put it like that. Okay, because I should have put that. A to the 10th will stay. B to the negative 5th will come down here. C to the 25th will stay here, and I'm just going to. A to the 5th, this is going to stay here, and I'll put it over here. B to the negative 20 is going to come up here. And C to the 10th will come up here. Can I rearrange things? Yeah, so let's see. Well, negative 3 to the third, negative 3 to the fifth power is 243, but negative, so I'm going to write 243. So that's taken care of. A10 and A5, we're going to have some A's left over, but it's going to be on the numerator. B20 and B5, right? B to the 20th power and B to the 5th power. So I'm going to have definitely 15 B's left over in the numerator. And then these two, we're just going to keep the base at the exponents. Right? So A to the 5th power times B to the 15th power times C to the 35th power over negative 243. Am I done? No. I think not. Okay, one more problem. This one looks scary. All right, so I'm going to. Let me change things around. All right, so all I did was switch left to right. So I am going to slowly apply BC cubed times, and again, if you want to switch positions, right, the numerator goes denominator and denominator goes numerator and make that a positive, you could have done that right away. But I'm going to take care of that -3 over here. Okay, so again, I get -3, and then a to the 9th, b to the -12, and again, there's that -2 outside, and that's all I did. I removed that parenthesis there. Okay. You could definitely over here, guys, you could definitely combine some like terms. What is that number? 8? Oh, that's a 9. Okay. You can definitely combine some of them if you want to. It's really, 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 really up to you. Can I combine something? Can I make this less of a mess and then multiply it by -2? Or if you want to, you multiply by -2 for everyone right now. It's really a matter of choice. So I don't, well, you know what? Let's just take care of that -2. Let me put a 1 over here. So that's going to be 4 to the -2nd power, a to the -4th, b to the -2, right? There's an invisible 1 here. C to the -6. 2, that 2 is -3 and -2 is going to be 6, right? A to the -18 and b to the +24. That's what I get in my numerator. At the bottom is 2 to the -2nd power, a to the -10, b to the +6, which is 6, and then c to the 10th, -10th. Maybe I should have simplified before I did that. Maybe. All right. Continued over here. Okay, 1 by 1. 4 to the 2nd power comes down. A to the -4th power is going to come down. B to the big that comes down. B to the 2nd power, -2nd power comes down. C to the negative that come down. It's exponent positive. 2 to the 6 stays up. A to the -18 comes down. B to the 24 goes up. Now the bottom part, 2 to the -2, that's going to go up. I'll take care of all the numbers later. A to the -10 goes up. B to the 6 is going to come down. Stay down, sorry. And C to the -10 goes up. All right, so now that everything's positive, it makes a little bit. So 2 to the 6 is 2, 4, 8, 16, 32. So let me write that. 32, right? This is 32. And 2 to the 2nd is 4. And 4 times 32 is, I don't know, 128. This and this is taken care of. 4 to the 2nd is 16. So I'm going to leave that over here. Now let's see if we can take care of a few things here. Let's do the A's. Well, there's A10 here, A4 and 818. So there's A4 and 818 is 8 to the 22nd power. Right? And then if I simplify that with A10th and I cross a bunch of them out, I'm going to have 12 A's left over at the bottom. B's, I have B2 and B6, B to the 2nd power and B to the 6th power, which means B to the 8th power. But there's a b to the 24th power in the numerator, so b to the 8th and b 24th, and all that, I'm going to have b to the 16th power on the numerator left over. C, well, C looks like my easy one. I have 6 C's at the bottom and 10 C's at the top. If I simplify a few of them, I'm going to have 4 C's left over in the numerator. 128, well, if you think about the fraction 128, right, so if I give you a fraction 128 over 16, can we simplify that? Yeah, we can divide both top and bottom by 16. And if I divide top and bottom by 16, I'm just going to get final answer 8. That simplifies to this. And then B16, C4, A12. You probably should have been better if I, over here, okay, if I combine some of the A's and combine the B's. Probably better, okay, but you can pick your own path, okay, and that's it.